Hi Abigail, this is Brother Dixon. What I'm going to do here is go through a handful of the problems that you missed on your exam. I won't go through all of them, but hopefully this will be able to help you get some confidence so that way you feel good in retaking the exam. If you still have questions after this, please feel free to reach out to me. We can try and figure out a time that works for both of us that hopefully is a reasonable hour of the day for you, and then we'll go from there. So, as you can see, I've already got number 2 written up here. There's the problem there, negative 3/7 times m minus n equals 3 plus 6m. So when you have these type of problems, the first thing you always want to do is get rid of your fractions. You could multiply this negative 3/7 into the parentheses and then go from there, but in the end you're going to want to get rid of that fraction anyway, so let's just start off by doing that. So I'm going to multiply by 7 on this side, but then what I do to one side, I got to do the other side. And it's important to remember to kind of put parentheses around there because we want that 7 to get multiplied by both of them. So now on my left side, I'm just left with negative 3m minus 9. And then on this side, I'm going to go ahead and distribute that 7 in there. So I'm going to get 21 plus 42m. Now I'm going to go ahead and distribute this negative 3n to break down the parentheses. So I'm going to get negative 3m, and a negative times a negative is a positive, so plus 9 times 3 is 27, equals the same thing over here, nothing changed. Now I want to go ahead and start combining like terms. So I want to get the m's together and then the whole numbers together. So I'm actually going to subtract 21 from here, subtract 21 from here. So this side it cancels out, and then on this I'm going to add 3m here, so that cancels, and then I'm going to add 3m over here. So now when I combine like terms, I got 27 minus 21 gives me 6, and then on this side I got 42 plus 3 equals 45m. Okay. Now in order to get m by itself, I'm going to divide by 45. That cancels that out, but what I do to one side, I got to do to the other side. So 45. Now I've got my answer of m equals 6 over 45, but I want to get this in the lowest term. So I see that 3 would go into both of these, 3 would go into 6 2 times, and 3 would go into 45 15 times, so I get 2 over 15 equals m. Okay? So the key on this one was really getting rid of that fraction to begin with, and then remembering to multiply your the number on the outside of the parentheses to both numbers. And as always, in all these problems, you're going to just want to pay close attention to your negatives. Make sure that those cancel out and distribute properly. So, okay, so that was number 2. Let's go ahead and jump into the next one, which is number 5 I've got here. So number 5. Okay, so number 5 is D equals LR R2 all over R1 plus R2. And it asks us to solve for L. Okay? So these problems always seem to throw people off because we're used to seeing numbers and all that. Well, the same rules apply here. First is the previous one. First step we want to do, get rid of our fraction. So how do we do that? Well, if we multiply this side by what's the denominator, so the whole side by R1 plus R2, if we do that whole thing, then that's going to cancel and that's going to cancel. But then we know what we do to one side, we got to do the other. D times R1 plus R2 equals LR2. And you could say, well, now I could distribute this, but you know, we're not really dealing with numbers. We don't have to do that. And this actually is considered simplest terms when you don't have numbers. So we're just going to leave it as D times R1 plus R2. And then I come back over here now to isolate L by itself. I'm going to divide by R2. Those cancel out. And I get L equals D times R1 plus R2. And since I divided this whole side by R2, I got to divide all this by R2. Okay, so pretty similar to the first one, but the difference being that you don't have any numbers, and so it kind of throws you off a little bit not having those numbers. Okay, let's go ahead and do the next one here. So the next one I've got written down. Pardon my son there. He's running around here while I'm trying to do this. Number 7, though, we have 0.76 times negative 2x minus 3 equals 0.19x plus 6. Okay, so this is going to be similar to the other ones. The difference now is that we're using decimals. So remember, on this exam you are allowed to use a calculator, and on this problem you're definitely going to want that. You could by hand multiply 0.76 by both these, but it'll just take longer. So use a calculator. I distribute that 0.76 into here so I can break down that parentheses. I need to do that before I can combine my like terms. So when I do that, I end up with negative 1.52x minus, sorry, I'm looking at my notes here, 2.28, and then nothing happened on this side, so I'm not going to change anything over here. Now I can go ahead and start combining my terms. I want to get my x's on one side and my whole numbers on the other, so I'm going to subtract 0.19x here. But then when I do to 1, I got to do the other. 0.19x here. And then I'm going to add 2.28 here. And then I'm going to add 2.28 here. So these cancel. These cancel. I combine my x's there. I end up getting, so negative 1.52 minus 0.19 is the same thing. I always, my trick for subtracting and with negative sometimes it gets confusing. So I say anytime I subtract, it's the same thing as adding the opposite. And so now I just add these two and I keep my negative sign. So I get negative 1.71x equals 8.28 because I combine these two over here. Now I can divide by negative 1.71 to get x by itself. I'm going to do that to both sides. And then I get x equals, sorry, this is a negative. I forgot that negative on there. X equals negative 4.84. So you want to make sure, if I would have forgotten to bring that negative over, I would have got positive 4.84, which I do think is one of the answers. Throughout this exam, you'll notice that there's a lot of the same number, and one's positive and one's negative. So you want to make sure that you're carrying your signs so that way you don't make a mistake there, because you may have felt like, oh, I got the right answer, but if you forgot that negative, then you might have marked the wrong one. So okay, there's that one. Let me go ahead, pull up the next one. The next one I have is number 8. Sorry. This is number 8. Put a little box around there so you remember. Number 8, 2x minus 6 equals 20. So similar to the previous problems we've done, we're going to add 6 here to get that gone. So what I do to one side, I got to do the next side. So then I get 2x equals 26. And then divide by 2 here. So that cancels. So I'm going to divide by 2 there. And I get x equals 13. Very similar to the other ones, a little simpler because we didn't have to distribute anything into parentheses or get rid of fractions, which was nice. So moving on to the next one, we've got, so you missed number 12, but number 12 was very similar to number 7 and number 8, so I'm not going to go through that one right now. The next one I am going to go through is number 13. So number 13 is one of these simplifying ones. So it says simplify, and it says 25 x to the negative 3, y to the negative 2, all over 35 x to the 5th and y to the 4th. Okay, so we just want to, we see we got a lot of similar terms. We got 25 over 35 here. We know we can reduce that. We just want to get this basically kind of in its reduced form. So I'm actually going to leave the 25 over 35 here, and I'm going to focus on the variables first. So in our exponent rules, anytime something is raised to a negative number, that is saying the same thing as if we were to take that x to that number and put it in the opposite position. So if it's in the numerator like we have here, we can move it to the denominator, and then it would just be x to the third. If you have x to the negative third in the denominator, you move it to the numerator, and then it becomes positive. So I'm going to move my x to the negative third and my y to the negative second down to the denominator. You could use the rules also of when you want to combine terms, when you have a variable raised to a number, you subtract the powers. So you would say negative 3 minus 5. That would work as well. But I do this way because it just visually, I like to write out each step, and I like seeing this. So my x to the fifth doesn't get moved because it didn't have a negative or anything. But I'm going to move that x to the third to the denominator. And you'll notice now that it no longer is negative because I was able to get rid of that negative because I moved it to the denominator. And then you got y to the fourth. So again, that didn't change because that was positive. And then I've got y to the second because I moved that down. So I see I've got no variables in my numerator. Now I can just use my my rules, and where I say, okay, if I've got two variables that are raised to some power multiplied by each other, then I can add their exponents. So next step is 25 over 35. I haven't done anything there, but I'm going to combine my x's. So 5 plus 3 is 8, and 4 plus 2 is 6. So now I've taken care of my variables with their exponents. Now I'm going to look at this 25 and 35, and I say, okay, 5 goes into both of those. So I'm going to get 5 over 7 x to the 8th, y to the 6th. Sorry, I don't know why I did another x there. And there is our answer. Okay, so if you're not familiar with these exponent rules, go back to, I want to say it's lesson 9 where we talked about exponents. Check some of those out. But that's kind of the trick there, is making sure that if you bring them down to the denominator, then you lose the negative, and then you can just easily combine terms. What would have happened, I'll just show you real quick. Let's say I would have gone with the rules where you say I'll just subtract it. I would have done negative 3 minus 5, which would have given me x to the negative 8. And then same thing over here, I would have done negative 2 minus 4, which would have given me y to the negative 6. And then but because those are negatives and we don't want to leave them as negatives, and we still would have had 25 over 35, then your next step would have been to say, okay, well, because they're negatives, I bring them to the denominator. So that's two ways. And then you would have reduced the same here. So you would have said 5/7 and then x to the 8 and y to the 6 there. So two ways to do it. Whichever way is easier for you. You end up with the same answer, and you're really actually doing the same thing. It's just kind of going about it two different ways. So, okay, hopefully that wasn't too lengthy of an explanation. Let's go ahead and look at the next one, which is number 21. Now we get into some of these percentage ones. I think you might have missed a couple of these ones, so I'm just going to do one of them though. So number 21 here, it says 34 is 56% of what number? And at first when you read this, it sounds really confusing, but watch what happens when I write this out. We're actually going to take this and just turn it into an algebra equation. So I know that 34 is 56% of something. So if we remember back to the lesson where we're talking about this, whenever I say is, that's like the same thing as saying equals. So 34 is 56%, and 56% written as a decimal is 0.56, of what number? X, right? That's what X represents. It's a number that we don't know. Well, now that I've done it like this, now it's the same thing as I do in any of my other algebra problems. So I can just divide by 0.56, and that's going to cancel here. I divide this by 0.56, and then that's going to give me X, which is that other number. If I do that math, I end up getting 60.7 as my answer. So these percentage problems are kind of tricky because sometimes they'll say is, sometimes they'll say of, and it's really, once you get it written into an algebra form, it becomes really easy to solve it. So jumping into the next one, I think it's a similar one, but it's a little more wordy. So number 24, it says I don't think I'm going to write out the whole thing, but the population grew. So I'm just going to say pop grew 9% up to 54,863. 863. Okay, and then it wants to know what was the population, the original one. So I'm going to just write pop again for population. Okay, so what was that original population? So we are now at 54,863, and it grew 9% in the last year. What was it a year ago? So since we knew it grew, one kind of hint here, when you're taking a multiple choice exam, since we knew it grew, we know the number we're looking for has to be less than 54,000, right? So if you end up with an answer that's like 55 or 56,000, that's a quick indicator that, okay, maybe I didn't do something right, because we grew up, so the number I started with has to be smaller than what I ended with. So in order to get this, to figure this out, I kind of think through it, and I say, okay, well, if I wanted to calculate out how much the new population is, using the old population numbers, what would I do? Well, if I had the old population number and I times that by the growth percentage, right? That would tell me how many more people I added in that year. It wouldn't tell me my overall population. It would just tell me how many more people in that year. So in order to find out the total population, I need to add that to that original population, and then that's going to give me my new population. All right? So this is kind of everything written out. This is how many people were added in the last year. This is my original, and then this is how many people there are now. So I look up here at my word problem, I say, okay, do I know any of this information? Well, yes, I know how many the new population is, right? So I can plug this number in here. I know what the growth was. I know the growth was 9%, so I can plug this number in here. And then I've got this variable that I've called pop, which we could easily call x if you want. And now I can write out my equation. So I say x times 0.09 plus x equals 54,863. And now I can solve for that x. Well, this is like having a 1 in front of it, so you can combine this and you get 1.09x equals 54,863. And now just solve for that x. So I'm going to divide by 1.09, cross that out, and I'm going to get x equals 50,333. Okay, so I look at this and I say, okay, good. The number I got is less than what the new population is, so I feel like I'm in good shape there. Seems pretty reasonable, so I feel pretty confident in my answer. So This one was just kind of a little tricky. It's really trying to extract that data, understand what they're talking about. I think for me, when I get it in this form here, it kind of like, okay, now I get it. So, I want to, in order to figure out what a new population is, I can figure out how many people were added to the original population, make that into kind of my variables, and then and go ahead and solve from there. So, unfortunately, this is all the time I've got right now. So I hope you found this useful, and that you feel a little better ready for the test. I'll go ahead and reopen that. Let's see, today's Wednesday, which is pretty much almost Thursday your time. I'll reopen it for another week. And so until next Wednesday, give you some time to listen to this, maybe try some of the problems out again, and then go in and retake that test. So just let me know if you need anything else, and I hope you have a great day.